everyone, hope all of you are doing well. In the last videos we were discussing the previous question papers and answers from the chapter Electricity of grade 10. Today also we are continuing with the same. If you have not watched till part 4, please watch it before going ahead with part 5. Can we move to the first question? The first question is asked in the year 2016. Okay, the question is, how will the resistance of a wire change when its length is doubled, its diameter is doubled and its temperature is increased? Here we have to write down the three cases in which how the resistance of the wire changes. Okay, so what is the first case? It is if the length is doubled. So how the resistance and length are related? Yes, we have studied that the length of the conductor is directly proportional to the resistance, right? As the length increases, the resistance also will increase. So how we can answer? If the length is doubled, then what will happen to the resistance? Yes, the resistance also becomes doubled. Okay, so first question is over now. Now what about the second question? Its diameter is doubled. If the diameter of the wire is doubled, what will happen to the resistance? Yes, the resistance is inversely proportional to the area of cross section, right? That is, R is proportional to 1 by A. So in this case, what is happening? The diameter is doubled. So what will happen? The resistance will become 1 by 4 times. Okay. The third case is when the temperature is increased. Then what will happen to the resistance? Yes, the resistance also will be increased. Okay. Now we can move to the next question. The next question is asked in the year 2015. The question is, a wire of length L and area of cross section A was drawn into a wire of double its length by melting it. If its original resistivity and resistance were rho and R respectively, what will be its new resistivity and resistance? Here we have a wire of length L and area of cross section A. Then what we are doing? We are melting it to make the length of the wire double of the original length. Okay. Then we have to find the new resistance and also the new resistivity of the wire. Yes, we have studied an equation to find the resistance of the wire, right? What was the equation? Yes, it is R is equal to rho into L by A. Right, here what is R? R is the resistance. Then rho, yes, it is resistivity. Then L is the length. Okay, then what is A? A is the area of cross section. Okay, now if you are finding the values of L and A, we can calculate the new values of resistance and resistivity, right? Suppose we are melting the wire, then what will happen to the length? The length will be doubled. Okay, so what will be the new length? That will be 2L, right? Then what about the area of cross section? What will happen to the area if the length is doubled? Means the area will be decreased, right? So that will be A by 2, half of the original length. Now we have the new length and new area of cross section, right? So how we can find the new resistance? Yes, we have the equation for resistance as R is equal to rho into L by A. Now we can substitute the new length and new area of cross section. Then what we will get? Then R dash will be equal to rho into 2L by A by 2, right? So that will be equal to 4 rho into L by A. That is equal to 4R. That is, the new resistance of is 4 times the original value. Okay, is it clear? Now we have one more question. That is to find the new resistivity of the material also. Okay, how we can find the new resistivity? We have studied that the resistivity of the material is independent of its dimensions, right? So even if the dimensions are changed, it will not affect the resistivity, so that it remains unchanged. Now we can move to the next question. The question is asked in the year 2015. The question is, state Ohm's law. calculate the resistance of a conductor if the current flowing through it is 0.2 ampere when the applied potential difference is 0.8 volt. Here we have to state Ohm's law. Also we have to calculate the resistance of the conductor, and the given quantities are the current and potential difference. Okay. Yes, how we can state Ohm's law? That is, the electric current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided its physical conditions remains the same. Right, that is, I is proportional to V. Now we have one more question, right? What is that? We have to calculate the resistance of the conductor. And what are the given things? That is 0.2 ampere is the current and 0.8 volt is the potential difference. Okay, so now we can write down the given quantities. That is, I is equal to 0.2 amperes, then V equal to 0.8 volt. Then how we can find resistance? Yes, that is, R is equal to V by I. Can we substitute? Okay, so what we will get? V is 0.8, so that will be 0.8 by 0.2, that is equal to 4 ohms. So that is the resistance of the conductor. Now we can move to the last question. The question is asked in the year 2015, and the question is, the resistance per meter of a wire is 10 ohm. If the resistivity of the material of the wire is 50 into 10 raised to minus 8 ohm meter, find the area of cross section of the wire. Okay, here what are the given quantities? Yes, the resistance per meter of a wire is given as 10 ohm. Right, what else is given? It is the resistivity of the material, that is 50 into 10 raised to minus 8 ohm meter. Right, but we have to calculate the area of cross section of the wire. Right, so is there any equation connecting all these quantities? That is resistance, resistivity, then length, area of cross section. Yes, we have R is equal to rho into L by A. Here R is the resistance, rho is resistivity, L is the length, then A area of cross section. Right, so that can we find A from this? Yes, we can cross multiply here, that is, R into A will be equal to rho into L. So A is equal to rho L by R, so that we can substitute the values of rho L and R. So that is equal to 50 into 10 raised to minus 8 into 1 by 10. So what is the value? Yes, that is equal to 5 into 10 raised to minus 8 meter square. That is the area of cross section of the wire. Is it clear? Today can we conclude now? Okay, hope it was helpful for you, and if you have not subscribed our channel, please subscribe. Thanks for watching.